These two 3D printed cubes were made using the same G-code on the same printer, but they came out very differently. One measures 20 millimeters, while the other is only 70 millimeters. And later you will see also the difference shows up in sensor data. So this is my Ender 3. It's a relatively old printer, and I wanted to test whether I could extract information about its condition just by mounting a sensor on it. The idea is simple. If the belt is loose, the printer should behave differently. To show that, I printed two cubes. The first one was printed with normal belt tension, and then I loosened the belt. I did not only loosen the screws, but then again I tightened it, so the belt is still in a loose condition but won't wobble around in an uncontrolled way. After doing that, I printed the same cube again. So here you see both cubes next to each other. They look relatively similar, but if you rotate them a little bit and take a closer look, you already see small difference in the print quality. The real difference becomes obvious once you measure them. For that I used a caliper, and here you see it clearly. One cube is 20 millimeters, while the other one is only 70 millimeters. To test this more efficiently, I created a custom G-code. Here you can see motion from the top view. First at low speed, then at higher speed. There are some minor visual differences, but I want to see whether I could also directly see this in sensor data. So for this, I used a small microcontroller board with a built-in accelerometer. With a little bit of wax, I mounted it on the hot end. And there you see a live demonstration of the data acquisition. As soon as it moves, also the acceleration sensor will show a lot of signal. For this analysis, I focused on the x-axis, as this was the axis that was mainly in motion. Here you see the raw acceleration signal, and it becomes even clearer that there is a large difference if the signal is slightly smoothed. Not only the acceleration peaks are clearly different, but the overall smoothness of the signals changes as well. With a loose belt, the signal becomes much shakier, while with a proper belt tension, the acceleration remains much more stable. So that are my findings for today, and maybe next time I'm going to implement a kind of algorithm that directly on the microcontroller itself can give like a signal if the belt is loose or if it's tightened up properly.